This is Numbers with Nicole. We're continuing our circle unit and using area of a shaded sector of a circle. In these last two model examples here, we're going to go backwards and we're going to solve for either the central angle or the radius or diameter, and we're going to be given the area of the sector of the shaded region or some part of the circle. We're going to be given the area for that. So let's dive in. So again, we're going backwards here. We're not finding the area of the shaded sector or the sector of the circle. We are finding some other piece that gives us that area. So a circle O has a central angle formed by a radius AO and OB. All right, well, let's sketch a picture here. Here's my circle. Here's my circle center O, OA, and OB. They said 60 degrees, so I'm going to estimate a little bit here, best I can do. They said this is 60, and they said that this area in here, area shaded, is 24 pi. Okay, so we have our proportion up here. Remember, we're going to compare the part of the circle to the whole circle. Okay, and we want to find the diameter. So in order to find the diameter, we need the radius, and the diameter is 2 times the radius. So we're going to solve for radius, and then we can find our diameter. So 2r. Okay, so let's start. All right, here's my proportion. Okay, the part goes on top. So the parts that we have are 60 degrees and 24 pi. Okay. We know for the total in the bottom that it's out of 360 degrees, and we don't know the total area. All we know is a formula for total area, which is pi times r squared. And so we want to solve this equation for r, and then using that r, we can get our diameter. Right? So solving this proportion for the unknown is no different than before. Okay, the only difference is here we have pi over pi, and we know that any number divided by itself, for example, 5 over 5 is 1, x over x is 1, so pi over pi will cancel to 1. So if they give you an exact shaded area, meaning there will be a pi symbol on it, that's good for us because that's going to cancel out. Additionally, what you can do is over here with your angles, if you want to, you could reduce that down before you do any calculation. You don't have to. It's not mandatory. See, that's a 6. That makes work a little bit easier for us. But again, it's not necessary. I'll write the reduced amount. So 1/6 is what 60 over 360 reduces to, and then I have 24 over r squared left. So when I cross multiply here, I'm going to get r times 1. Perfect. I'm sorry, r squared times 1, which is just r squared, and then I'm going to have 6 times 24. Okay, that works out nice. So r squared equals 144, but we need r so that we can get diameter. Take the square root of both sides, the opposite of squaring. We get that r is 12, meaning our diameter is 2 times 12, or 24. All right, we're going to do another example, and we're still going to be working backwards. So again, if we're using the same exact proportion, the only thing that we're going to be looking for this time is that we're looking for the measure of angle Q. So we don't know the angle. Again, lots of ways to do this final model here. I'm just going to go with how I know how to do it. Okay. So we know the area of the unshaded sector. So this is going to be 500 pi. Yuck. Okay, here we go. 500 pi. And then we know that our radius is 25 inches. So we can find the whole circle, the whole area. All right, so whole area for the circle would be pi times 25 squared. 25 squared is 625 pi. Okay, so here's one way that you can do this. I want the area of the shaded, okay? I could use the unshaded sector, find that angle, and subtract that angle from 360. If you're already plugging away and doing that, go for it. But what I'm going to do is this is the total area, and from that, I'm going to subtract the unshaded area and treat pi like it's an x. 625x minus 500x would be 125x. In this case, we're going to treat it like pi, a constant. And that is going to be the area shaded now. Ooh, so now I can set up my proportion comparing the part of the circle to the total circle. So what are we looking for here? We're looking for angle Q. You could put X, you could put something else there, some other variable. I like to name it with what it is. I have found that my shaded area, I should use a different color for that. Sure, we'll go with gray. Right, that has a area of 125 pi. And I know that the whole area is 625 pi. And I know that all the degrees in a circle is 360. So if you look over on the right here, we have pi over pi, which cancels out. We could reduce the 125 over the 625. I don't feel like doing that right now, so I'm not going to. So angle Q equals 360 times 125, right? When we cross multiply, that 625 would multiply times angle Q, and then we would just divide it again. So it's just going to stay down there. If you have to do that step to get your answer, that's fine. 360 times 125, divide that by 625, we get that angle Q is 72 degrees.